Good day, everyone. We are Group 7 and we will be tackling about an article related to digestive physiology. It is entitled Effects of Cellulase Supplementation on Nutrient Digestibility, Energy Utilization, Methane Emission by Boer Crossbred Goats. I am, by the way, Earth Callo, and I will be discussing specifically on the introduction up to the materials and methods used in this study. Cellulase has been reported that dietary addition of this compound increased the apparent digestibility of dry matter or DM, organic matter OM, and neutral detergent fiber or NDF of dairy cows. Addition of exogenous cellulase may increase total volatile fatty acid or VFA of rumen fluid of dairy cows without disturbing the VFA profile. Rumen VFA is the energy source for ruminants, and therefore it could be deduced that exogenous cellulase might affect energy metabolism of ruminants. This study hypothesized that energy utilization could also be affected by the dietary addition of exogenous cellulase, as the evidence for nutrient digestibility being elevated by exogenous cellulase accumulated. Thus, the objective of this study was to determine the effects of exogenous cellulase on nutrient utilization by Boer crossbred goats. Let's proceed to the materials and methods used. 12 castrated Boer crossbred goats, average body weight is 21.5 kilogram maximum and 18.5 kilogram minimum, and around 10 months old, were used in a 4-replicate 3x3 Latin square design. These goats were purchased from farmers around Chengdu, China, and the sexual maturity of this species is at 7 to 8 months until 12 months of age. They were housed individually in the metabolism cages designed to separately collect feces and urine. Before the experiment, goats were dewormed for parasites with albendazole at 12 milligram per kilogram body weight. Now there were uh, three experimental periods corresponding to 3 treatments. Each stage comprised 21-day periods, with the first 14 days as the adaptation period and the following 9 days as the measurement period, including 6 days in crates and 3 in chambers. From day 1 to day 6, goats were kept for feces and urine collection. On day 7, the goats were transferred into respiratory chambers. On day 8 and 9, for gas exchange measurements. In respiratory chambers for measuring oxygen, carbon dioxide, and methane output. Total feces and urine were collected daily both in chambers and in metabolism cages. Now, the DM or dry matter basis of experimental diet in Table 1 comprised of 30% concentrate, 35% alfalfa, and 35% Chinese wild rye, and was formulated to provide adequate digestible energy or DE and crude protein or CP for a 20 kilogram goat. These were fed to goats necessarily for twice a day with equal amounts at 1,000 and 1,600 hours, with fresh water available at all times. Basal diet with no cellulase added serves as the control, and the second treatment was added with 2 grams of unitary cellulase or UC per kilogram of ration dry matter, and the third treatment was added with 2 grams of CC or compound cellulase per kilogram of ration dry matter. The enzymes UC and CC used in this study were commercial preparations of fungal extracts. Live weight was recorded for 3 consecutive days in the morning before feeding at the beginning and end of each period. Urine was acidified with 10% HCl volume per volume, 5% of urine. Feces were preserved with 10% formaldehyde volume per volume, 3% of feces, and thoroughly mixed. Periodical refusals, experimental diets, and ingredients were stored at negative 20 degrees Celsius until analyzed. Also, urine and feces were subsampled daily after acidification and preservation and stored frozen at negative 20 degrees too. Feed offered, refusals, and fecal samples were dried in a forced air oven at 65 degrees Celsius for 48 hours, then ground to pass through a 1 millimeter screen and were analyzed for DM, gross energy or GE, and NDF or the filter bag technique. Concentration of oxygen, carbon dioxide, and methane were analyzed using gas chromatography. Reference gases 99.9% on all oxygen, CO2, and CH4. Temperature and humidity in the chambers was maintained at 23 degrees Celsius for oxygen, 50% for CO2, and 55% for methane. So now, let me introduce Trixia Macalam, who will be tackling further about the methods used in this article.
For the calculations, metabolizable energy intake was calculated. So metabolizable energy, it is the net energy remaining after fecal and urinary energy loss. It also represents the energy available for growth or reproduction. So it was calculated by the difference between the gross energy intake, the energy losses in feces, the energy losses in urine, as well as the energy losses in methane. Second is the heat production, which was estimated based on the Brouwer equation here. And third is the retained energy, which was determined by the difference between the metabolizable energy intake and heat production. For the statistical analysis, first, mixed procedure was used. So it is used to analyze the data. It is used to fit for a variety of mixed linear models the data, and it enables you to use these fitted models to make a statistical inference about the data. It has primary assumption that the data are normally distributed and that the means or the expected values of the data are linear in terms of a certain set of parameters. Second, the full general linear model or the GLM model, it is a useful framework for comparing how several variables affect different continuous variables in its simplest form. So in this study, the model included the fixed effects of square, B, the period nested within square, C, the treatment, which is the 3 diets, the control, which has no cellulase, the second diet is the utinary cellulase, and the third diet is the compound cellulase enzyme. D, the sampling time, and E, the interaction of treatment and sampling time. Duncan's multiple contrast was also used to separate the means. For the results and discussion, this table shows us the effects of enzyme treatments and apparent nutrient digestibility and end metabolism in growing goats. So there are 16 items or the variables that was determined in this study. And looking through the live weight, the dry matter intake, dry matter digestibility, the organic matter digestibility, the NDF, and the ADF digestibility, as you can see here in this underlined values, we can see that the values are not totally different. For the live weight and the DM intake, the 3 diets, the control, the cellulase, and the compound cellulase are just the same. For the DM digestibility, OM digestibility, NDF, and ADF digestibility, the 3 diets only differ by insignificant amount. So looking through the right side of this table, the p-value. So the p-value, it is used in hypothesis testing to help decide whether to reject or to reject the null hypothesis. So the 16 variables or the 16 items used in this study is greater than 0.05. So what does that mean? It means that the live weight gain, and the DM intake among treatments has no significant difference. The following variables also were not affected by the cellulase treatment since these values are greater than 0.05. A review of related literature, there are some studies that observed a positive effect of treatment with exogenous cellulase on DM or organic digestibility, and this is in the study of Lewis et al. And Rudd et al. 1999. Some other also observed no effect, according to Lewis et al., McAllister et al., and Young et al. 2000. In this present study, it results that the cellulation addition had no effect on DM and OM digestibility. So these contradictory reports may be due, according to Young et al., to the digestion characteristics of the ration. Yang et al. Noted that the exogenous cellulase improved the digestibility of low-quality rations, but no effect was observed with high-quality rations. However, in O'Connor et al. 2000, he found that nutrient digestibility even decreased when cellulase was added to high-quality diets of horses. There are also therefore, this only means that the effect of cellulase on nutrient digestion is still incompletely understood. However, there are studies that indicates improved digestibility caused by exogenous cellulase that was due, according to Wang et al. And Morgave et al., to improved microbial colonization. So they have found associative effects between exogenous cellulase and cellulase from rumen organisms. For the nitrogen balance, there was also no difference among the treatments since the p-values is greater than 0.05, the N intake, the fecal N, and the urinary N. Second, the N retention and N retention rate was also not affected since p-value is greater than 0.05. There are also studies that found no effect on nitrogen rate of lamb after the addition of cellulase at 20 grams per day, according to Awaude and Ubidat studies. In Gado et al. Also, he added cellulase at the rate of 40 grams per day in cows' diet and found no effect on NR and utilization.
Okay, let's start. Thank you, Ms. Trixia. For this time, I will be talking about the effect of exogenous cellulase on energy metabolism. But before that, why do we need to study the energy metabolism? Well, all living things, including the goat, need energy to survive, to grow, reproduce, and so on. And energy is derived from the nutrients it eaten, and it undergo a process called metabolism. Metabolism is a set of chemical processes that transform chemical energy stored into an energy for cellular processes. So why is it important? Because it represents the most important body function and has an effect on energy spent. For the experiment, if the p-value is greater than 0.05, it means that it has no effect or no effect was observed. As we could see in the table below, the result shows that the p-value is greater than 0.05. So we could say that the exogenous cellulase has no significant difference to the gross energy intake, fecal energy, and urinary energy extraction, methane energy, heat production, and the retained energy among treatments. Then, for the methane emission, why do we need to study methane emission? Because it is a hydrocarbon that is primary component of natural gas, which is also a greenhouse gas that is present in the atmosphere affects the Earth's temperature and climate system. Methane emission from ruminants is receiving an increased level of public attention. So we need to study it to know if cellulase could reduce the methane emission from ruminants. For the experiment, just like earlier, if the p-value is greater than 0.05 means that it has no effect or no effect was observed. And as we could see in the table below, the result shows that the p-value is greater than 0.05. So we could say that the exogenous cellulase has no significant differences among dietary treatments of total methane emissions. Methane emission as a proportion of live weight or feed intake, or the methane energy output as a proportion of energy intake. And for the conclusion, we could conclude that the cellulase addition had no effect on dry matter intake, nutrients digestibility, and nitrogen utilization in goats. Gross energy intake, fecal energy and urinary energy excretion, methane emission, heat production were also not affected by the supplementation.
Thank you, Reshe, for that informative discussion. The results showed that exogenous cellulase has no effect on nutrients digestion and nitrogen utilization in goats. Therefore, it implies that supplementation of cellulase may not be an effective additive for reducing the methane emission. So that ends our discussion about the effects of cellulase supplementation on nutrient digestibility, energy utilization, and methane emission by Boer Crossbred Goats by Lizhi, Wang, and by Shu. We thank you for listening and we hope you have a nice day ahead.